Thanks.
Now zoom back in a little bit.
No, I'm good.
Yeah.
I'll cut off the top.
We're back from the commercial break, everybody.
Okay. Anyway. So when I do the top, outside. Pi, now my radius to the outside, think about it, the radius to the outside is what? 1. Isn't it constant? Yes? No?
Yeah.
Does anyone see that it's just that line 1? So it's going to be pi. Now the inside, my radius, if I draw to the inside of that, see I just go to that inside function? Yes?
Yeah.
But problem, my inside is not x squared plus 1. Why?
Because you moved it up one, so it's just x squared. Oh, I know.
Oh. Square root of...
Yeah, exactly.
Y.
And that's the biggest mistake everybody makes in this. They may do this whole problem beautifully, but forget that you better solve for x. So my inside radius is square root of y minus 1. Okay, we've got to be very careful. We're evolving about the y. Everything better be in terms of y. That's what gets everybody right there. So I have pi times y minus 1. So my integral, I'm going to go ahead and factor out my pi, outside minus inside. We'll clean that up in a second. So my outside is just 1 when I factor out the pi. It doesn't go away, it's still 1. Inside is y minus 1. Now I'm going from what to what? We know we're going from 1. Now if you want to find where these meet, think about it. That curve and 1. Well, it's saying x is 1, correct? When I plug in 1, I get 2, correct?
Yes.
So at 1, I'm at 2. So from 1 to 2. Now let's clean that up. I have the integral from 1 to 2. That'll be 1 minus y plus 1, so I really have 2 minus y dy. Yes, no?
Yes.
Okay, so I'm going to have 2y minus 1/2 y squared. Evaluate from 1 to 2. We'll worry about the pi later. Plug in 2. I'll get 4 minus 2. Plug in 1. I get 2 minus 1/2. So that'll give me 2 minus 3/2, which is 1/2. Yes? No? All that?
Yes.
Put the pi back in. So I really have pi over 2. Not done.
You need to add it.
I need to add it. Don't forget my cylinder. So pi plus pi over 2. You could do common denominator if you need it. 3 pi over 2. So the volume of that entire shape is 3 pi over 2. But this problem, if you have a good picture, is not hard. The hard part was realizing that this does not have a hole. So I did not need to do that in an integral. I could just use a cylinder. Okay? Questions?